Dr. Sally Cooper, and I am here with
Professor Andy Newsam. Hello.
And we are going to tell you all about the solar system and beyond. Okay, so I'm Sally and this is Andy, and we are both astronomers, and that means that we study space, and space is really big and has lots of interesting things in it. But what can you tell me about space? What can you see in this picture? And it's okay to shout out. So what can you see? Galaxies. And there's lots of interesting stuff there. And one of those things, the nearest things to us, is the moon. So when you're outside at night, you might notice a big white blob in the sky, and it's called the moon. And the moon is the Earth's neighbour and friend, and it orbits around the Earth. So it continually goes around the Earth, and it takes about 28 days, or approximately 1 month. Now the moon is really hot in the day when the sunlight's on it, and really cold at night. And what else do we have? So, next thing away is we have the planets. So this one here is Jupiter, but we also, the nearest planet is Mercury, that's the closest planet to the sun, and all of the planets go around the sun, just like the Earth does. And Jupiter is the biggest planet in the solar system, and you can fit around 1,000 Earths inside Jupiter. So what else do we have in space? Well, I mentioned the sun, and the sun is a type of star, and it's this big burning ball of gas, hydrogen, and it's in our sky, and it's our nearest star. But there are lots and lots of stars in the universe, in space, and the stars make up something called galaxies. And I will come to how many stars are in galaxies later. But our galaxy is called the Milky Way, just like the chocolate bar. And so what else do we have in space? We also have something called nebula, and they are where stars are born. And they're really dusty and gassy, and it's kind of like a star nursery where all the stars are born.
So, that's some of the things we look at in space, but obviously, if we want to know how things work in space, we have to be able to see them. And you can just go out and look, but you won't see very much because our eyes aren't really very good at looking at the sky. We use things like this. What is this? Telescope. Now this is my telescope. This is the one I have at home, and I like my telescope. It's about this big, and it's great to take out at night, but there is a problem with my telescope. And the problem is, my telescope is really old. This telescope is even older than I am, which is saying something. So this is a very old telescope. And that means if I'm using this telescope, I can't see things that people couldn't see 100 years ago when the telescope was made. And so if we want to see new things, we need a different kind of telescope. Not one about this size, but one that's quite a lot bigger. And these are some of the telescopes we actually use to look at the universe and find out new things about space. And there's 3 ones here. I'm going to start with this one down here. Now that doesn't look much like a telescope, does it? It's a bit weird. What you're doing there is you're looking down into the telescope. The telescope is pointing out of the screen straight at you. And that red thing in the middle there, that's a man. He's about as tall as me. So this is a really big telescope. You're not going to carry this one around. And we use really big telescopes so that we can see further and further away and fainter things. And that's a really good way of looking at things in the universe. But sometimes even that isn't enough. Sometimes even a really big telescope like this isn't enough. And then we put our telescopes into space. Now, can you put your hands up if you can think of a good reason why you might need to put a telescope into space? Yes?
So like, since farther out, you can see more.
You are further out. You're a little bit closer, aren't you? But there are other reasons as well. Anybody think of another reason? Yes?
Because when the satellites are in the house, you can see more of the galaxies.
You can see more. Yes, you can see a lot more. Good. Any other reasons why you can see more when you're in space? Yes, over here.
Because when you're in Earth, you can't really like see it all. So then when you're in space,
That's good, isn't it? Because if you're on the Earth, you can't see anything that way because the Earth's in the way. If you're in space, you can see an awful lot more. Any other reasons? Yes? Can you shout a little bit? That's true, yes, that's another good one. I like that one. But there's a very special reason. Can you put your hands down for a second? There's a very special reason, and that's to do with what there isn't in space. Now, if I was out in space, would I just be wearing these clothes? Now, what would I be wearing if I was out in space? Yes?
astronaut clothes.
Astronaut clothes. I'd be wearing a spacesuit, wouldn't I? Now, why do I have to wear a spacesuit if I'm in space? Yes?
There's no oxygen.
There's no oxygen. There's no air, is there? Now, that's a bit of a problem if you're out in space without a spacesuit, but it's really good for astronomers because the air's a bit of a nuisance to us because the air is what makes stars twinkle. Who knows the nursery rhyme, Twinkle, Twinkle, Little Star? Yeah, you all know that? Good. Now, if you go out at night and you look at stars, they do twinkle a bit, don't they? But stars, as Sally just told you, are like the sun. And the sun doesn't twinkle, does it? It's big and bright and hot. So stars aren't actually twinkling, they just look like they're twinkling. And that's because the air makes them twinkle. And that means when we take pictures of stars, they're fuzzy. We don't want fuzzy pictures, we want good, sharp pictures. And that's why we put telescopes into space. It's because then there's no air. And the pictures are really sharp because there's no twinkling. So that's a really important reason why we put telescopes into space. And then we have other telescopes like this one, which is a nice big telescope, and it's hundreds of miles away. And this is a special telescope for looking at how things change in space. And we're going to be using some pictures from this telescope a little bit later.
So we can put our telescopes in space, like Andy said, but one of the other things we can do is send people into space. And they can do astronomy from space, but not just that, they can also do lots and lots of other types of science from space. And this picture behind me is of something called the ISS, the International Space Station. Now, the International Space Station essentially is a giant laboratory in space where you can do lots and lots of science experiments. And not just astronomy, but you can learn how plants grow in space or how humans live in space. And so one of the things in space, one of the things that we don't have in space the way we do have on Earth is something called gravity. And we can't feel the effect of gravity. Now, gravity on Earth is what makes us come back down to Earth. So if I jump, I come back down. And that force that pulls me back down is gravity. And in space, there isn't as much gravity, and that affects the people and also the conditions. So the International Space Station is somewhere we can send humans to go and do science and also live there. So sometimes astronauts go up into space for, say, 6 months at a time, or even up to a year is the longest time someone has spent on the International Space Station. Now, the first British person to go to a space station, it actually wasn't this one, it was one of them before. It was a Russian space station called the Mir. So Helen Sharman was the first British astronaut on a space station back in 1991. And then since then, you might see this familiar face. It's Tim Peake, who recently went to the International Space Station in 2015. And he went up to conduct lots and lots of science experiments, and schools got involved and helped him with that too. So before we actually went to the space station, we went to the moon. And it was about 50 years ago this year that humans actually landed on the moon and were walking around the moon. And when they were there, because there was a lot less gravity, they were sort of jumping around and floating around. Now, as I said, that's gravity that we don't really have once you're away from the Earth. So if I play this video, this is Tim Peake when he was in space at the International Space Station, and what he's going to do is his friend's going to twist him round and round and round. Now, we'll play the video. Oh.
But I'm feeling absolutely fine. That's quite remarkable. I think if I was on Earth by now, I'd be feeling very, very unwell.
Without a doubt.
And I've got my eyes open, I'm moving my head. When I move my head, that is definitely provocative, and that gives me some off-axis. But again, it's not making me feel sick. That's quite weird. Okay, if you want to stop me.
Yep.
Okay, I'll see if I can. I'm feeling dizzy. I'll see how quickly it stops. So it definitely felt dizzy initially, and now it's gone.
No, is that quick?
Yeah, completely normal.
Amazing.
Yeah, and again, I wouldn't be able to kind of just get off a fairground ride spinning that quickly for so long. I feel normal. Yeah.
Crazy.
It is amazing.
It's a good demo.
Yeah. Okay.
Oh, that makes me feel a bit sick, even just watching it. And definitely if you were on Earth and you were being spun around that fast, you would definitely have a funny belly and feel a bit sick. And that's partly because you have an idea when you're on Earth of what's up and down, because you know down is the way you fall down to Earth because of gravity. But because Tim Peake is in space and there isn't as much gravity, he has no real sense of what's up or down. And actually when astronauts first go into space, for the first few days they feel sick because they're getting used to not having gravity. But once they've been there a while, even though Tim Peake was getting spun really, really fast, round and round, he doesn't get that feeling of dizziness the way you would on Earth. Does anybody want to watch that again? Yeah.
But I'm feeling absolutely fine. That's quite remarkable. I think if I was on Earth by now, I'd be feeling very, very unwell.
Without a doubt.
And I've got my eyes open, I'm moving my head. When I move my head, that is definitely provocative, and that gives me some off-axis. But again, it's not making me feel sick. That's quite weird. Okay, if you want to stop me.
Yep.
Okay, I'll see if I can. I'm feeling dizzy. I'll see how quickly it stops. So it definitely felt dizzy initially, and now it's gone.
No, is that quick?
Yeah, completely normal.
Amazing.
Yeah, and again, I wouldn't be able to kind of just get off a fairground ride spinning that quickly for so long. I feel normal. Yeah.
Crazy.
It is amazing.
It's a good demo.
Yeah. Okay.
So that was Tim Peake, and he is the most recent British astronaut in space and to be on the International Space Station. And he's a scientist and does lots and lots of different jobs on the space station. Does anybody here want to go to space? Lots of you, but not all of you. Some of you might not want to go to space, but you might still be interested in space. And that's good. You don't have to go to space if you're interested. There are lots and lots and lots of jobs that scientists do in the space industry. So along the top there are different types of careers that you could be if you were interested in space but didn't necessarily want to go. And they include astrobiologists, and they are people that study the biology of being in space and actually are looking for possibly the signs of life outside of our planet, otherwise known as aliens. So that's a cool job. We also have astronauts, so like Tim Peake and Helen Sharman, who go out into space and do science experiments. We also have astrophysicists and astronomers, just like us here. That's what we do. We do research into those things that we talked about, stars and galaxies. We also have engineers, so those amazing telescopes that Andy showed you, and also the space station, is a big engineering. Somebody has to think about how to make these things. How do you put things in space? That takes an engineer, and any of you could be engineers. We also have planetary scientists, so understanding the planets and what they're made of, as well as space lawyers. Because what if we all move to Mars? Who's going to govern us? Who's going to tell us what to do? Who owns the moon? So it's questions like that that space lawyers answer. And then we have space medical professionals, or otherwise space doctors, who are trying to understand the effects of space on our body and what it would be like to live in space permanently, or if we move to Mars, how would it affect us? So that's only a small range of jobs that you could do in the space industry, and so only one of them is being an astronaut and going to space. And you could do any of those jobs, and in fact they're people just like you and I who make up the space industry. In the UK alone, there are approximately 70,000 people working in the space industry. Now, to give you that as a comparison to numbers, Anfield, the home to Liverpool, seats around 50,000 people, and to make things equal, Goodison Park, home to Everton, seats around 40,000 people. And so the space industry employs, that means there's at least 70,000 people in the United Kingdom that are working in those different space jobs, and that would be more than enough to fill the stadium at least once, close to twice over.
So, we can take people out into space and we can put telescopes out into space, but the only place we visited, the only place outside the Earth that we sent people is the moon. And you might think that's a bit weird because we've got all these other places that we'd like to go to, galaxies and planets and things. And the problem is, all of these other places are really far away. And we're going to do a little experiment now to see just how far away some of these things are. So, I want you to use your imaginations a bit. And I want you to imagine that this marble, that you can probably only just see, is the entire Earth, okay? So that's all of the Earth. Us, America, Australia, all of that is on this little marble. Can you imagine that? Yeah. Yep, some of you can, good. Well, keep imagining that. Because what we're going to do now is we're going to see how big the moon would be compared to the Earth. Now, put your hand up if you think the moon is bigger than the Earth. A few of you, okay? Put your hand up if you think the moon is smaller than the Earth. Okay, that's most of you, so we're going to go for smaller. So I brought a little moon with me. See if I can find, oh, there we go. There's my little moon, okay? Which you probably can't see at all because it's tiny. But that's how big the moon is if the Earth was as big as my marble, okay? But what I'm really interested in is how far apart they are. So we're going to try a little experiment again here. So put your hands down for a second. And I'm going to hold them really close together. And I'm going to slowly move them apart. And I want you to put your hand up when you want me to stop. Okay, when you think they're the right distance apart. So if the Earth really was this size, and the moon really was this size, excuse me, how far apart would they be? So put your hand up when you want me to stop. Okay, starting now. That's pretty much everybody will stop there. That's a pretty good guess, but it's not quite right. They're actually that far apart. So the moon is really far away. And that's a bit of a problem, because that's as far as we've got. But we also know there are other bigger things out there. So we saw the picture earlier of Jupiter. And we know that Jupiter is bigger than the Earth. So I brought a ball along to be Jupiter. Does anybody think that's big enough to be Jupiter if the Earth was that size? A lot of no's. I think I need something bigger. So what I've done is I bought a balloon. And what I'm going to do is I'm going to blow the balloon up, and you have to stop me when you think it's big enough, okay? But if you don't stop me, I will keep blowing, and Jupiter will go bang, and we don't have Jupiter anymore, okay? So you've got to be careful. Are you ready? You want me to stop, okay? Is that big enough? Are you sure? Is that big enough? Oh, it's going to get risky. If you don't like things to go bang, you might want to put your finger that's quite big, isn't it? Remember, this is the whole Earth. And this is now the size of Jupiter. But the main thing I care about is how far apart they are. And to find that out, I'm going to need a helper. Somebody willing to help me. Amina is going to come down and help me. Can you come down here? Brilliant. Now, I want you to be Jupiter, okay? So I want you to hold Jupiter, and I'm going to be you. We come over here a little bit so we've got a bit of space, right? And what I want you to do is very slowly walk over towards Sally, and you're going to tell her when to stop, okay? So put your hand up, or shout out when you think she should stop, okay? Are you ready for this? So start walking over towards Sally over there, very slowly, okay? Tell her when to stop. Stop! Sure, that's far enough. So I did a bit of thinking earlier, and I did some measuring, and I measured the size of my marble, and I measured the size of the balloon, because I had a good guess how big it was going to be, and I worked out how far away Jupiter would really need to be. So wait there for a minute, and I'm going to show you some pictures about where you need to go to, okay? Is that right? So we're going to start off here. So that's us, and there's the Earth there. Now can anybody see Jupiter? No, okay. Let's go a little bit further. No. Oh, look, there's something over there. Does anybody know what that is? Quiet, please. Somebody thinks that's an orange. Who thinks that's an orange? Okay. I think it's a bit bigger than that, because remember, the Earth is this size. So that would be a really big orange. I think that's the sun. So we still haven't found Jupiter. We've got Earth here, which is this size. We still haven't found Jupiter. So hold on a minute. Go a little bit further. You still can't see it. A little bit further. Still can't see it. There we go. That's where we are. And there's Jupiter. So can you head off? And you need to go down the middle. Can we give her a fantastic round of applause? That was brilliant. So Jupiter is really far away. If we're here and Earth is this size, and Jupiter's the size of that balloon, it's all the way over there in Kensington. Anybody know that part of Liverpool? Yeah. A few of you? So you know how far away it is. Most people would get a car to go that far. I'm a bit of an idiot and I walk, but most people would get a car to travel that far. So that's a really long way, and that's when the Earth is this size. So that's why we haven't sent people to Jupiter. It's just too far away. And that's not even the furthest planet. If we keep going out a little bit further, and a little bit further, we see this one over there. Does anybody know what that planet is? Neptune! Excellent! That's Neptune! And it's so far away it's left Liverpool. So everything in the universe is really, really big. And that's why we have to use these big telescopes, because otherwise we can't see what's going on out there. We can't go to the planets and galaxies and stars. We use telescopes to see them. And there's lots of things we try and study in space. And Sally will tell you about some of them.
So that was our solar system, and one thing that's right next to the Earth, and Andy showed the distance between, was the Moon. And that's our nearest object in space. And it's one of the things that we study. And in fact, the National Schools Observatory, which is where me and Andy are from, you can take your own pictures of the Moon. But there are some things that we don't still understand. So if you're standing out there on a clear night, you'll see the Moon. But have you ever wondered, where did it come from?
Yeah.
How was it made? We've already been back to the Moon, but are we ever going to go again? So, does anybody think they know where it came from?
I think it came from like 400 years ago. It was an asteroid and then all the asteroids came together to make the planets and all that.
So possibly an asteroid within the solar system and made lots of the other objects. Does anybody else want to have a guess where it came from? Go on, you seem really keen.
I think that a meteorite came and smashed half of the Earth and then caught together.
So possibly something smashed into the Earth and produced that big piece of the Earth was broken off and formed the moon. Well, actually, that's kind of similar to our best guess. As scientists, we don't actually know where the moon came from. It's one of the things that we're not sure about. And that's why we're astronomers, and we want to find out more about space. So, can we ever get to the moon again? So we went 50 years ago, humans stood on the moon, and since then, we haven't been back as humans. So, do you think we'll ever go again? Yeah, maybe. So, some other things that we think about as astronomers and scientists are there aliens? Do you think there are aliens? Has anyone ever seen an alien? Okay. So, I have never seen an alien. Yes, but Andy was telling you about the sun and the solar system and all the planets that go around the sun like Earth does. But have you ever thought about what if there are any other planets outside of our solar system? So I can tell you that there are other planets. There are other solar systems. There are other planets that go around other suns, other stars. In fact, we've discovered about over 2,000 of them now, and that's only in about the last 25 years. So there are other planets, which means, are there other planets that are like Earth? And is it possible to live there? And what do you need if you were going to live on another planet? Even if it was Mars, what would you need to take with you? So there are lots and lots of other planets. And then those 2,000 that we found is only a small number of planets that we've discovered in our own galaxy. And there are lots and lots of other galaxies. So potentially, there might be other things living in space on one of those planets. So maybe, although we've not found them yet, there might also be aliens. So I said that we found lots of these other planets, and there's lots and lots of other stars. But how many stars are there? So can you tell me what this is a picture of? Yeah, I heard lots of you say it's a galaxy. Do you know how many stars are in a galaxy? What's your guess?
I was going to say there's over a trillion or billion because in each galaxy there's like over a billion stars.
A trillion billion, there's definitely over a billion stars. Does anybody else want to make any other guesses? Go ahead, Bert.
In one galaxy, I think it's 100 trillion.
100 trillion. So do you think higher or lower? There's about 500,000 million. Whoa! How many is that? So we've got, in this one galaxy, 500 billion stars. Now, when you're talking that kind of numbers, it doesn't really make sense to us anymore. We just stick a load of zeros on the end. And that's what 500 billion looks like as a number. Now that's one galaxy. So we are here on Earth around the sun. The sun is a star. And there are around 500 billion stars in our galaxy, in one galaxy. But what about the rest of space? So if you were to go outside on a relatively clear night, maybe not in Liverpool, you might see a sky that looks about a bit like this, lots of stars. Do you know, first of all, what the reason why it might be difficult to see this many stars from Liverpool? If you were in the city centre. Right up there. Go on. Shout up. Because there's pollution. Yeah, so Liverpool city centre is full of lights. And that's really bad for astronomy, and it means that you struggle to see the night sky. But if you went a bit further out into the countryside, you might see a sky that looks a bit more like this. Now, in the middle of that picture, you can see a little yellow shape. And can anybody see anything in that little box? No, there's nothing there. So when you look at space at night, you might think that it's relatively empty, there's a few stars in the sky, but actually, if I zoom in to that little shape, you can see this picture. This is from a telescope called the Hubble telescope, and that's a telescope that was in space. And can anybody tell me what you can see in this picture? Yeah, over this side.
Different coloured stars.
Different coloured stars. Anything else? Go on.
Different, like the planets you said before that you found out.
So maybe it's planets, maybe it's lots of other stars. Anybody else? They're twinkling. Some of them are twinkling. Anything else?
Little galaxies.
Little galaxies. So there are some little galaxies in there, but actually there's quite a lot of big galaxies in there. And nearly everything that you see in this image is a galaxy. So these aren't the stars that you see in the sky that are near to us. This is actually looking into the deepest parts of space. And so if I go back, in this tiny little shape, just a really small part of the sky, you can actually see this many galaxies. So remember that we had 500 billion stars in one galaxy. And how many galaxies do you think there are in space? So if I say 500, higher or lower?
Higher.
What if I say 1,000?
Higher.
A million?
Higher.
A billion? So this is another image of another really small part of the sky. And this is the deepest image that we've ever taken of space, of the universe. And it's with the same telescope, but when it was upgraded, and it's called the Ultra Deep Field. And so you can see, other than this, so there are some stars in this picture, and they're the ones that have little crosses on them, and that's the stars that are really close to us. But other than that, everything else in this picture is a galaxy, small or large. And they come in lots of different shapes and sizes. Some are spirals, like our Milky Way. Some are big, blobby ones. Some of them look like little disks. So all of those, even the little specks, are galaxies. And now if we just have a little look at this one close-up region of space, you can see some of those galaxies up much closer. So you can see some of the nice patterns and the colours of the different galaxies. Come back to it. We'll come back to the number of galaxies.
So that's lots of things that are really far away and really, really big. But we don't just look at things that are really far away and really big. Sometimes we look at things that are quite close. We look at things like this. You've just seen this picture. This is an asteroid. Now, what does that look like? Put your hands up. Yes. It looks like a rock, doesn't it? That's because it's a rock. Doesn't sound very exciting, but asteroids are really interesting rocks. They're really interesting because they're very old. Asteroids were made at the same time as the Earth, but since the Earth was made, it's changed quite a lot. It's got volcanoes, and it's got weather, and it's got oceans, and it's got us. The Earth has changed. These haven't changed very much. So if we look at asteroids, and we really study them, we can work out what the Earth used to be like. So we can see how it's changed, and how it might change in the future. So that's one reason why we're interested in asteroids. But the other reason is they're quite big rocks. And they're moving really fast. And so we don't want them to hit us. Because if they hit us, we might all die, which is really bad. So we've got to find these things and stop them hitting us. And we're going to have a go at doing that together to see whether you can help us find these asteroids. And we're going to start by looking at a picture like this. Now this is a picture of what we took with that telescope I showed you at the beginning, the special telescope. And I want you to put a hand up if you can see an asteroid in that picture. I'm going to give you a clue though. It's not that one. Really? Okay, hands down. Now I've cheated a little bit. Because this is the picture straight off the camera. And the cameras we use on these telescopes are much better at seeing things than our eyes are. So we have to put the picture into a computer and use the computer to show us what's really there. We call it image processing. And if I image process this, we see a bit more. And then a bit more. And then even a bit more. And that's probably about as far as we can go. So now, you should be able to see everything there is to see in this picture. Now put your hand up if you can see the asteroid. Quite a few people. Now remember that it's possible, not likely, but possible, that this asteroid could one day come and hit the Earth. So if you're wrong, we're all going to die. No pressure, okay? So who thinks they can see this asteroid? We've got lots of hands. I'm going to come up to you. It's all right. Why do you think it's that one? That's really good. This was going for this small one here, because asteroids can be small. They're certainly smaller than stars and planets. Who agrees with her? Who thinks she's right? Oh, quite a few of you. Good. Who thinks she's wrong? Oh, more of you think she's wrong. So how many of you are absolutely certain you know which one it is? Put your hands up if you're absolutely certain you know which one the asteroid is. Quite a few of you. Put your hands down. Put your hands up if you've got absolutely no idea which one the asteroid is. Okay, let's go. It's tricky, isn't it? Okay, put your hands down again. The problem is, asteroids are quite small and they're reasonably far away, so they tend to look like little dots. And stars are much bigger, but they're much further away. So they tend to look like little dots. So we're comparing dots and dots, and that's not very good. All we can really do is guess. We can have intelligent guesses, that was a good guess, but we're still guessing. And we don't like guessing in astronomy, we don't like guessing in science. We like to work out the right answer. So we need to think a little bit. And we need to tell the difference between stars and asteroids. We need something that asteroids do that stars don't do. What do asteroids do that stars don't do? Yes. Sorry? They travel. They move. They're going round and round the sun just like the Earth. Stars aren't. Now we can't see things moving with one picture, but if we take several pictures and show them one after the other really quickly, we call it blinking, we might see something move. So I'm going to do that now, and I want you to put your hand up when you can see something move, okay? So can you see anything moving in a nice straight line? Keep repeating. And Mira has found it in the middle. So put your hand up if you saw that one. Excellent, well done. Did anybody see something over here going flash? Yeah! The one up there. Now they're not asteroids. They're actually not stars, they're not galaxies, they're nothing like that. They're what we call cosmic rays. Great name. They're tiny, tiny little things, smaller than an atom, and they're hitting the camera. And so that's why we need lots of pictures, 3 or 4 pictures, so that we can see things moving in a nice straight line. And you're really good at this, so if you want to go and do this for yourself, we have a website, we'll pass that on to your teachers as well, and you can come along and you can help us do this. Get the pictures, do the image processing, and look for things that move. So, we've had a look out in space. We've seen how big things are. We've seen how many of some things there are. We've had a go at finding asteroids. We've learned about what the different things people do to get people out into space and to study space. And so what we've done is we've tried to answer a few questions. I'm afraid we're going to have to stop now. I know, I'm sorry about that. So thank you very much indeed.